Okay, question number 12. All right. So on question number 12, part A says factorize fully 6y squared minus 5y minus 4. All right. So there are actually many ways that we can actually use to, factorize this quadratic expression over there. But I'll just show you one of the ways that I normally urge most of my students to use. So we have 6y squared, right? Minus 5y minus 4. So the first thing that I would urge my students to do is to multiply the first term and the last term, right? So it's 6y squared times minus 4. So you're going to get 24y squared, right? And then you're going to look for two terms such that if you add them, um, they're going to give you minus 5y, right? And then if you multiply them, you're going to get minus 24, right? So 6y squared times minus 4 is minus 24y squared, by the way. All right, so I'm going to look for two terms such that if I multiply them together, they give me minus 24y. If I add them together, I get minus 5y. So I could think about 8 and 3. So if I have minus 8 plus 3, I'll definitely get minus 5. And if I multiply minus 8 times plus 3, I'll also get minus 24. So the two terms that I'm looking for is minus 8y and plus 3y. So minus 8y plus 3y are going to substitute this minus 5 over here. So I'm just going to take this same equation, but replace minus 5y with 8y plus 3y. So minus 8y plus 3y minus 4. All right. So I'm now going to like factorize this expression over here. So I'm just going to first pair them up, right? So here 6y minus 8y, I'll factor out a 2y, right? So that I come up with um it's actually a 6y squared, right? All right. And then I'll come up with 3y minus 4, right? And then on 3y minus 4, I'm just going to factor out 1 because 1 is common between 3y and minus 4. So plus, I factor out 1, right? And then 3y minus 4, right? And then I'm going to take this repeating bracket, 3y minus 4, 3y minus 4. So I now have 3y, right, minus 4. This is my first bracket. And then take this 2y plus 1 and 2y plus 1. So this is now your answer. If you factorize fully 6y squared minus 5y minus 4. So you're going to write 3y minus 4 and 2y plus 1. All right. Okay. And then question B. Question B says that express 2x plus y over 4x plus 7 minus 5x all over 3x as a single fraction in its lowest form. All right. So the first thing when you're dealing with algebraic fractions, right? You need to come up with a common denominator, right? So the common denominator that we can come up with over here is by actually multiplying these two denominators, right? So we have 4x and 3x. If you multiply 4x and 3x, all right, you're going to come up with 12x, right? 12x squared, isn't it? So we're gonna come up with 12x squared. So 12x squared is our common what? Our common denominator. So we now have 12x squared is our common denominator, right? And we do that. Okay, so now if you take this 4x, right, and is you divide it into this 12x squared, you're going to come up with 3x. So you now have 3x over here multiplying 2x plus 1. And then you also take this 3x right there, right? Divide it into, so there's a plus here. Divide it into this 12x squared, right? So you're going to get 4x. So you put the 4x here, right? And then it's multiplying 7 minus 5x. All right. So I'll try to expand this bracket over here. So 3x times 2x, that's 6x squared. 3x times plus 1, that's plus 3x. And then you move on to the second bracket, 4x times 7, that's plus 28x, right? And then 4x times minus 5, that's minus 20x squared, all over, right, 12x squared, isn't it? All right, so I'm now going to simplify like terms on the numerator, right? So I have 6x squared, right, minus 20x squared. So that's definitely going to give me negative negative 14x squared, right? So I have negative 14x squared, and then 3x plus 28x, I'll get 31x. So plus 31x all over, right? All over 12x squared. All right. So I'm going to factor out a x from the numerator, right? So if I factor out x from the numerator, I'm going to end up with minus x, right? 14x minus 31 all over 12x squared. So this x is going to cancel out an x over here, right? So my final answer is going to be minus, this minus multiplies everything inside this bracket. So it's going to be minus 40, right? X plus 31 all over 12x. So this is your answer, all right? This is your answer. So minus 14x plus 31 all over 12x. This is your final answer, all right? So this is how you solve this problem over there. The first thing that you have to do, you have to come up with the common denominator, which was 12x squared, and then you now use that common denominator to solve the rest of the problem. All right. Okay. Let's move on to the next question. Question number 13. All right. So question number 13 reads, Hammond has 2 bags of beads. All right. And in bag A, there are 3 white beads and 7 black beads. In bag B, there are 5 white beads and 4 black beads. Hammond takes at random a bead from bag A and a bead from bag B. So Part A is asking us to complete the probability tree diagram. So by just looking at the number of beads in bag A and bag B, you can actually see that in bag A, right, which is this first bag over here, right, you have 3 white beads and 7 black beads. So altogether you have 10 beads, right? So out of the 10 beads, 3 of them are white beads. So you're going to put it 3 over 10 here for the white beads. So it's 3 over 10. And for the black beads, it's 7 over 10, right? And then in bag B, there are 5 white beads and 4 black beads. That means we have 9 beads in bag B. And out of those 9 beads, 5 of them are white. So in bag B, you have 5 over 9 white beads and 4 over 9 black beads. So you do the same here as well. 5 over 9 white beads and 4 over 9 white beads, black beads, I mean to say, right? Okay, now from here, they want us to work out the probability that Haman takes 2 beads of the same color. Haman takes 2 beads of the same color. So we're going to have a combination of colors over here. So if he picks 1 bead from the first bag, right, and then picks another bead from the second bag, bag B, right, the probability that it's going to pick 2 white beads is here, and this one is a probability of picking a white bead first and then a black bead second. This one is for a black bead first and then a white bead second, and this one is for picking 2 black beads. So we're actually looking for the probability where he takes 2 beads of the same color. That means we're going to take white and white, which is 3 over 10, right, times 5 over 9, right? And we also take this one because it also shows that he picked 2 beads of the same color, black and black, right? So you take 7 over 10 multiplied by 4 over 9, right? So the product that you're going to get from this and the product that you're going to get from this, you add the 2, right? And the sum of these 2 products will give you the probability that Haman picks or takes 2 beads of the same color. So in short, we're trying to say that we're just going to write 3 over 10 times 5 over 9 plus 7 over 10 times 4 over 9, right? So if you solve this, you're going to come up with 43 over 90, right? You can as well write it as a decimal, which is around 0.477. It keeps on recurring, so you just say 0.47, right? So I'll write 43 over 90. All right. So that is our answer over there. That is our answer over there. Let's move on to the next question. Question number 14. All right, question number 14 says the combined savings of Abel and Bahira are 15,435 dinars, right? The savings of Bahira are 45% more than the savings of Abel. The savings of Bahira are 3/2 times the savings of Chanda, right? So the first relationship that we've been given is between Abel, let's say the ratio, right? Which is surely the relationship actually, of Abel and uh, Bahira, right? So we've been told that the savings of Bahira are 45% more than the savings of Abel, right? The savings of Bahira are 45% more than the savings of Abel. So if you're going to look at the savings of Abel and Bahira, you see that Bahira savings are 45% more than Abel's savings. So if Bahira's savings are, I mean, if Abel's savings are X, right? Then Bahira's savings are is definitely going to be 1.45x because Bahira savings are 45% more than Abel savings. All right. So the first thing that you have to do is to actually find the value of x. So the total ratio of Abel and Bahira is actually going to show us the combined savings of Abel and Bahira. So in other words, the total ratio is x plus 1.45x, right? Which is actually equivalent to the total savings that they have, which is 15,435 dinars, right? So if you add x plus 1.45x, you're definitely going to get 2.45x, right? Okay, so to get the value of x, I'm going to divide both sides by 2.45, right? X is going to give you you're going to get 6,300, isn't it? 6,300. So this will give you 6,300 dinars, right? So this one is the value of x. X is equivalent to 6,300 dinars, all right? But we've been told that the savings of Bahira are 45% more than the savings of Abel. And we actually want to use Bahira's savings to find Chanda's savings, right? So what we're going to do is we now know that X is 6,300. So we want to find how much Bahira actually had. So Bahira's ratio was 1.45x. So Bahira's savings is equal to 1.45x. So it's now 1.45 multiplied by 6,300 dinars, right? So if you multiply 1.45 times 6,300, you're gonna get 9,135. So you get 9,135 dinars. All right. So 9,135 dinars is Bahira's savings. Now we want to find Chanda savings. So they actually told us that the savings of Bahira are over 2 times the savings of Chanda, right? So a Chanda's savings, right? We've been told that they are um, 3/2 times Chanda savings. I'll just put a comma here. Chanda savings, which is X, right? Uh, is equivalent to Bahira savings, which is 9,135 dinars, right? And of course, if you want to find the value of X, that means you're going to multiply a 9,135 by 2, and then you divide by 3 so that you actually have the value of X over here, right? So of course, if you multiply 9,135 by 2 and then divide it by 3, you're going to get 6,090 dinars, right? So your final answer is 6,090 dinars. All right. All right. So let's move on to the next question, which is question number 15. All right. So for question number 15, they say that the function f is defined as f of x is equal to 3x plus 1 all over x minus 2. And the first part of the question wants us to state the value of x that cannot be included in any domain of the function f. All right. So this one is quite easy. You just look for the value of x on the denominator, such that if you substitute that value, you're going to get a 0. The reason why I'm saying that is because if ever you try to divide by a 0, your answer is going to be undefined. So that would be a value that cannot be included in any domain of the function f, right? So if you substitute positive 2 on x, you see that it becomes plus 2 minus 2, and then you get 0. And if you have 0 on your denominator, you cannot divide that number like any number divided by 0. It becomes undefined. So the value of x is definitely going to be 2, right? So that value that cannot be included in any domain of the function f is positive 2. All right, moving on to the next question. They say that express the inverse of the function f of f of -1, power of -1, in the form f of -1 x. That's just inverse of a function of f of x. All right. So the first thing that we know is that f of x is equal to 3x plus 1 over x minus 2. So I'm going to replace this f of x with y. So I now have y is equal to 3x plus 1 over x minus 2. All right. So I'll try to make this x subject of the formula, right? So making x subject of the formula, the first thing that I would do, obviously, is to get rid of the denominator, whereby I'll multiply both sides by x minus 2, right? So this x minus 2 cancels out this x minus 2. And then I now have this x minus 2 multiplying y. So y times x, I'm going to get xy. And y times minus 2, I get minus 2y, which is equal to 3x plus 1, right? Remember, I want to make x subject to the formula, right? So I'm going to take all the terms with x over to the same side. So I now have xy. I take this 3x to the left, and then it becomes minus 3x. My bad. Let me just get rid of that y. Okay. All right. Minus 3x, which is equal to 1, this 1, and then this 2y goes over there. It's negative 2y, so it becomes positive 2y, right? And then I factor out x from here. So if I factor out x, I'm going to get x, y minus 3 is equal to 1 plus 2y. And then because I'm trying to make x up this formula, I'm going to divide both sides by y minus 3, y minus 3. So this x is now the inverse of x. So it's now f of x is equal to, right? These y, I convert them to x. I convert them to x. So it becomes 1 plus 2x over x minus 3. So this is your final answer. So f of inverse of x, right, is inverse of f of x is 1 plus 2x and then x minus 3. That is your answer there. All right. And then we move on to question number 16. Question number 16. Question number 16 reads, there are 20 sweets in a box. 15 of the sweets are red and 5 of the sweets are yellow. Fred takes at random 3 sweets from the box. Work out the probability that Fred takes at least 1 sweet of each color from the box, right? So the total number of sweets is actually 20, and then 15 of the sweets are red and 5 of the sweets are yellow. So this one should we should actually use a probability tree diagram to solve this question, right? Because they want us to work out the probability that Fred takes at least 1 sweet of each color from the box. And then we actually know that Fred takes 3 sweets from the box. So of course, when he's taking a sweet, he's not going to replace it. He's taking it and keeping it. That means the probability is going to decrease by 1 on each stage. So we're going to start with this probability whereby Fred picks the first sweet, right? And then we move on to the second probability whereby Fred picks the second sweet. All right, so we actually do the same over here as well. And then we move on to when Fred picks to pick the last or the third sweet. So it's going to look like that, right? Okay. All right. So we have a probability tree diagram that's going to look like this. All right. So of course we have R for red and Y for yellow. So that's what we're going to have. Red, yellow, red, yellow, red, yellow, red, yellow, red, and then yellow. All right. So they say that he had 15 red sweets and 5 yellow sweets. So 15 over 20, right? The total number, and then 5 over uh 20. All right. So of course you can go ahead and fill up all the other probabilities like over here, because when he picked a sweet from 15 over 20, that means if he picked a one red sweet, uh, it's going to be left with 14 red sweets and a total of 19. So it lowers like that. So this one is 13 over 18, right? And of course, this one's going to be 15, not 15, but actually 5. My bad. So it's 5 over 19, right? So same thing happens here. It's going to be 4 over 19 and then 3 over 18, right? So you can actually go ahead and finish up the whole diagram. But okay, let's just finish up the whole diagram and then I'll show you how it's going to look like. So this 13 over 18 is here we're going to have 5 over 18 and this is 5 over 19. So this one's going to be 4 over 18 and this one is definitely going to be 14 over 18. So this one is 3 over 18. This one is 15 over 18. And this one's 4 over 19. So this one's going to be 15 over 19. And this one's going to be 14 over 18. And this one's going to be 4 over 18. So the question wants us to work out the probability that Fred takes at least one sweet of each color from the box. At least one sweet of each color from the box. All right. So the probability that they actually want is this probability and this probability and this probability and this probability and this probability as well as this probability. You find these probabilities, you find the total of these probabilities, and then that will be the answer that I actually want. But I actually think that would take quite some time. So to save time, I'll find the probability that Fred will pick the same color, which is red, 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 yellow, yellow, and yellow. I find the total of these two probabilities, then I subtract them from 1. So if I subtract them from 1, I'm going to get the probability that he picked at least one sweet of each color now, right? At least one sweet of each color from the box, all right? So the probability here is going to be for red, 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 it's 15 over 20 plus 14 over 19 plus 13 over 18, right? And the probability of getting a yellow, yellow, yellow is going to be 5 over 20 plus 4 over 19 plus 3 over 18, right? So you find the total of these two probabilities. Then you subtract from 1. Then you subtract from 1, right? So in other words, this is what I'm trying to say. 1, so probability that Fred is going to pick at least one sweet of each color from the box is going to be 1 minus, right, the total of 15 over 20 plus 14 over 19 plus 18 over 18, right? Plus this probability, 15 over 20 plus 4 over 19 plus 3 over 18, like that, right? And then you're going to get 45 over 76. You're going to get 45 over 76. So 45 over 76 is your final answer. That is your final answer. All right. Okay. Number 17. So number 17, these actually surds. They say it show that 1 plus root 5 over 3 minus root 5 can be written in the form a plus root of b. A plus root of b. So this question is quite easy, right? What you just have to do is rationalize over here. So I'm going to multiply by 3 plus root 5 and 3 plus root 5. The reason why I did that is I want to get rid of a surd, right? Or let's say a root on the denominator, right? So to do that, I have to multiply by, if I have 3 minus root 5, then I have to multiply it by 3 plus root 5, all right? So solving this, 1 times 3, obviously I'm going to get 3. 1 times root 5, that's plus root 5. Root 5 times 3, I'll get plus 3 root 5. Root 5 times root 5. So root 5 times root 5, I'll just get 5, right? Because if it's like you have a root 5 times another root 5, you get it. It's like root 5 times root 5, you get root of 25, and then root of 25, of course, it's just 5. So that's how I got this 5 over there. So it's all over. Let me just try to fix that. Okay. All right. So it's all over. 3 times 3, that's 9, right? So it's a difference of 2 squares, right? And then 3 times root 5, I'll get plus root 3 root 5. And then minus root 5 times 3, I'll get minus 3 root 5. And then minus root 5 times plus root 5. I'll get minus 5, right? So of course, my plus 3 root 5 minus 3 root 5 is going to give me 0. This guy is going to give me 0, all right? So I'm now left with 3 plus 5, that's an 8, right? And then root 5 plus 3 root 5, that's plus 4 root 5, all over. I now have 9 minus 5, that's 4. So 9 minus 5, that's 4. All right. So in other words, I now have this 4 as a common denominator for 8 and 4 over 5. So in other words, it just looks like this: 8 over 4 plus 4 root 5 over 4. So if I divide this 4 into the numerators, so it's 8 divided by 4, I get 2. Then this 4 divided by this 4, that's 1. So plus root 5, right? So this is your answer. So your answer is a 2 plus root 5. I just try to make this look perfect. Okay. So 2 plus root 5 is your final answer. All right. Number 18. A curve C has equation y is equal to x cubed minus 40x plus 1. Find the coordinates of both the points on C at which the gradient is 8. All right. All right. So the first thing that you have to do over there is to know how to find the gradient of a curve, right? So the gradient of a curve, if you're given the equation of the curve, you have to find the first derivative of that equation, all right? And then when you find the derivative of that equation, if you're given a certain point, like a certain value of x, like find the gradient of the curve at a certain point or a certain point, and then you're given the value of x, you just substitute that value of x in the first derivative equation. So if you if the equation is of the curve is x cubed minus 40x plus 1, I'm going to find the first derivative of this equation. So dy dx, right? I'm just differentiating this equation. So I'm going to get 3x squared, right? Because, you know, if you're differentiating, it's just if you have a x and then you're differentiating this, it's going to be this n multiplies the a, so n times a, right? And this x, and then you remove 1 from the n, isn't it? So that's what I did over here. It's 3 times the coefficient of x here is 1, so 3 times 1, I got 3, and then I subtracted 1 from this 3 over here, right? So it became 2. I'll do the same thing here. So if you differentiate negative 40, you're just going to get in the negative 40x, just going to get 40. If there's no x, then there's nothing actually over here. All right. So the first derivative is actually the gradient. The value of this first derivative, if you substitute the value of x, right? A certain value of x in this equation, you're going to get the gradient, isn't it? So dy dx is the gradient of the curve, isn't it? So in other words, I'm trying to say 8 is equal to 3x squared minus 14, right? I take this negative 40 over there, and then I now have positive 40. That's 8 plus 40 is equal to 3x squared, right? So it's now 48 is equal to 3x squared. So I'm going to divide by 3 both sides, and this is going to give me 16 is equal to x squared. Find the square root of 60, right? So x is plus or minus 4, because if you square 4, positive 4, you're going to get positive 16. If you also square negative 4, you also get positive 16. And then mind you, we want to find the coordinates, right? So the coordinates for each value of x, there should be also a value of y, right? Because the coordinate is an x and y value. So let's first choose positive 4 and see what we're going to get. So we are now going to substitute these values of x back into the original equation, which is y is equal to x cubed minus 40x plus 1. So it's just f of what? Positive 4. That means 4 cubed minus 40. Then you substitute not 3, sorry, you substitute 4, right? And then you add 1. So if the value of x, the value of y actually, if you substitute 4, you're gonna get negative 95, right? And then f of minus 4, right, simply means you're gonna substitute negative 4 into the original equation, which is x cubed minus 4 minus 40x plus 1, so it's minus 40, and then minus 4, right, and then plus 1. So if you substitute minus 4, you're going to get a positive 97. Right. So you now have those values. So if x is positive 4, we figured out that y is going to be negative 95. And if x is negative 4, we figured out that y is going to be 97. These are your answers over there. All right, so we move on to question number 19. Question number 19. All right, so here's a quadrilateral ABCD. They want us to work out the value of x and they say give your answer correct to 3 significant figures. All right, so we want to find this value of x of here, all right, using the information that we've been given over here, all right, on the diagram. So the first thing that we have to do is to try and find a length of BD. Right? And then after we find the length of BD, we can actually use the cosine rule to find the value of x, angle x, isn't it? So for us to find BD, all right, we're going to use the sine rule. We're going to use the sine rule, right? So we can actually see that BC, right, is 12.8 meters. So it's complementing this angle here, 40, right? So we're going to write 12.8 over sine 40, right, is equal to BD over sine 62, right? So that's the sine we're actually using over there. So for us to get a BD, so BD is going to be equal to 12.8 times sine 62 all over a sine 40. So BD is going to be equal to if you enter those values, you're going to get 17.582 blah 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 blah, right? That's what you're going to get, right? So we now have the length of BD, isn't it? So if we now have the length of BD, we're going to use the cosine rule. So cosine rule is we can write it in this way, right? Cosine rule, right? It's like if you want to find c squared is equal to a squared plus b squared, this is b, minus 2ab, right, cos c, right? So BD is the length, is actually the length that we actually have over there, which is 17.582. 17.582. So it's more like 17.582 squared is equal to a squared. So these are the two sides, 13.4 and 15.2, right? So we have so we have 15.2 and 13.4. So 15.2 squared plus a 13.4 squared, right? Minus 2, my A is 15.2, my B is 13.4 cos C, which is the X that I actually want to find there, right? So I'll just say cos X, isn't it? Okay, so of course you have to make cos X subject to formula. So you're gonna have, let's say, cos X is gonna be equal to 17 point let's just put it in this way, say 17.582 squared, right? 17.582 squared. You're going to subtract this guy over here. Actually, it's because if we take if you actually take this cos X over there, right, this 17.582 will become negative. So let's put it in this way. So it's actually the total that we're gonna get from squaring these two guys, like 15.2 squared plus 13.4. So it's more like you get the total of these two guys, right? 15.2 squared plus 13.4 squared, right? Right, and then you subtract 17.582 squared. Of course, there is this 2 over here, and then you divide by 2 and the product of 15.2 by 13.4. Yeah. All right. So this will probably give you a, so cos X, if you successfully solve this, or this should give you a 0.247, right? And then it obviously goes on and on like that. And to find the value of X, you find the arc cos of 0.247, which should be should give you something like 75.6 degrees. So your answer is going to be 75.6 degrees. So that's what you do. So you first use the sine rule to get the length of BD. And then after you do that, you then apply the cosine rule to find the angle X. Okay. Moving on to question number 20. The diagram shows a sector of OABC of a circle center O. angle AOC is equal to 60 degrees. So this is the angle that they're talking about, which is equal to 60 degrees. The area of the shaded segment ABC is 38 square centimeters. So this is the shaded segment that they're talking about. All right. So work out the perimeter of the shaded segment ABC. Give your answer correct to one decimal place. So the perimeters, of course, they want us to find the length of AC and the arc AC, right? So arc of AC and the length of AC will definitely give us the what? The perimeter of the shaded segment ABC. So the first thing that we have to do is probably find these two lengths like OA and OC. We know that the length of OA and OC is also equal to the length of AC, right? And then we can actually use that to also find the arc AC, the length of the arc AC. All right, so from this statement that they gave us here, the area of the shaded segment ABC is 38 square centimeters. If you want to find area of this shaded part, so area of shaded, they just say segment, right? This is what they did. They actually found the area of the sector and they subtracted area of the triangle from the area of the sector, right? So the area of the sector, we use theta over 360 pi r squared, right? Minus the area of the triangle. So for the area of the triangle, they actually used half AB sine theta, which is actually sine 60, right? So AB, of course, AB is OC and OA, which is just radius, isn't it? So instead of writing AB, I would have just written R times R, which is R squared, isn't it? So from the information that we given, theta, they say it is actually 60, so it's just 60 over 360 pi R squared minus half R squared sine 60, right? And 60 over 360, that's 1 over 6, isn't it? So I'm going to get pi R squared over 6 here minus sine 60. Sine 60 is equivalent to, so you know, if you still know the using this triangle here, right? And then you split it up there, and then this 60, this becomes 30, this becomes 30, this becomes 60, this is 2, this is 2, this is 1, this is 1, and this length over there becomes root of 3. So if you want to get sine 60, right, you know that sine is equal to opposite over hypotenuse. So your opposite over here is sine 60. Let's say you're trying to find this angle right here. So opposite will be root of 3 over your hypotenuse will be 2, right? So that's what we're going to do here. So half r squared sine 60 is root 3 over 2. All right. Okay. So now that we have all this information, we can actually simplify this this problem that we have here, because this gives us the area which is actually 38 square centimeters, right? And try to find the value of the radius, right? So the value of the radius, of course, if you continue like solving this, you're gonna see that is gonna be I'm gonna factor out r squared from here. So it's r squared. Let me just remove this. Okay, okay, and put it here. All right. So it's gonna be r squared. If I'm gonna remove r, it's gonna be r squared. So 2 times 2, this one is gonna be 4. So if I remove this r squared, I'm gonna be left with a pi over 6, which is pi over 6, right? Minus this one will give me root 3 over 4, right? And if I want to get the value of r, because this is equal to 38. So that means r squared is going to be equal to 38 over pi over 6 minus root of 3 over 4. I'll just put it in brackets. Then I get r squared. So if you want to get the value of r, let's continue here to get the value of r, not r squared, but the value of r actually, because we want to find the value of r. So to find the value of r, we're gonna have to find the square root of that whole guy over here, which is the square root of 38 all over pi over 6 minus the root of 3 over 4. Okay, so this is going to give us the value of r. So if you enter these values in the calculator, you're going to find out that r is going to give you 21 or 28, that's my bad, 21.481, right? So you're gonna get this. So this one is the value of your r. This is the value of your r. So you now know that this is 21.481. This is also 21.481. And this here is also this length AB, right? AC, my bad, is also 21.481, right? But you need to find arc AC. You need to find arc AC. Now, for you to find arc AC is just, so to find arc AC, it's theta over 360, right? Times 2 pi r. So that's going to give you the arc of AC, the arc of AC. So it's just so to find AC, arc of AC, right? It's 60 over 360 times 2 pi, and the new radius is 21.481. So this is going to give you 21.448. 448, right? 21.448. All right. So after you get that 21.448, because you actually want to find the perimeter of the radius, I mean the perimeter of the shaded segment ABC. right? So it's going to be the 21.48, which is AC, right? So AC is 21.481 plus the arc AC. Did you see that? Is this from A, right, to C, this length here, and this arc here, length of this arc here. So this length here is 21.481 plus this arc here, which is 21.448, right? So that will give you the perimeter of the what? Of the shaded segment ABC. So the perimeter is simply going to be 21.448 plus 21.481, right? So if you solve these two, you're definitely going to get 41.9 is your final answer. So your final answer is 41.9 centimeters. 41.9 centimeters. All right. Okay. Let's move on to question number 21. All right. Question number 21 says a curve has equation y is equal to f of x. There is one minimum point on this curve. The coordinates of this minimum point are 5 and -4. Write down the coordinates of the minimum point in the curve with equation. So you have to know all the transformations, like all the rules that you have to apply when you're transforming a certain equation, right? So for the first one, it's x plus 7. It's inside the bracket. That means it's actually affecting the x axis, x values to be more specific, right? So if it's plus, then it's a translation. If it's inside the bracket, it's a translation. And if it's plus, it's showing you the direction it's moving. So if you see a plus, it means it's moving to the left. If it was a minus, then it was moving to the right, right? So x plus 7, it simply means that it's moving 7 steps along the x-axis in the negative direction, right? So on on the coordinates of the minimum point, you look at the value of x. So the value of x is actually 5. So you're going to subtract 7 from the value of x, right? So if you subtract 7, it's like 5 minus 7, you're going to get -2. So your x value is now -2. There's nothing that is happening in the y because this is a translation in the x-axis and it's moving 7 steps to the left. So your new coordinates are going to be -2 since the translation along the x-axis and nothing is happening to the y value, so -4. And then for the second one, y is equal to f of x -6, right? So if it's outside the bracket, right? This one is showing you a translation along the y-axis. If it's outside the bracket, it's along the y-axis, right? If it's positive, then it's going up. The translation is actually shifting upwards. But if it's negative, then it's moving downwards. So this one is negative. So there's no effect whatsoever in the x-axis, right? But it's actually a translation along the y-axis and it's moving down, right? So you look at the y value, which is actually -4. So it's going down. So it's -4 -6. and then you're gonna get minus 10, right? So this is along the what? The first one was along the x axis, and this one is along the y axis. So it's minus 10. So there is no change in the y value, the x value. So the x value just remains 5 because we're using this point over here. But the y value is going to change to minus 10, right? Okay, so that's what we have for number 21. Let's see if we have any more questions here. All right, so we move on to question number 22. Okay, question number 22. The incomplete histogram shows some information about the distances in kilometers that 100 adults ran last week. All right. And then they said all of the adults ran at least 5 kilometers. That means our histogram, our frequency density diagrams should actually, I mean, not our histogram, let me say, our histogram should start from a point from 5 here, because all of the others, they ran at least 5 kilometers. That means there is nobody who actually ran less than 5 kilometers. So all of them ran 5 kilometers and above. So none of the adults ran more than 55 kilometers. That's why you see here, there is nothing after 55 kilometers. All right. So we're actually using this histogram to solve this problem. So they said 14 adults ran between 15 kilometers and 20 kilometers. So from 15 kilometers, I'm here, right, to 20 kilometers, that's here. We actually have 14 adults. So you have to know that if you are making a histogram has a frequency density on the y, and um, the distance on the what? On the x, right? According to this histogram that we're actually solving. So if you want to calculate the frequency density, right? So just put it as that. Have frequency density is equal to the frequency divided by the, let's say, class width, right? So over here, we can actually see that they told us that we actually have 14 adults, right? Who ran between 15 to 20 kilometers. So the class width from 15 to 20, you can actually see that 15 to 20, the class width is 5. So it's 5, right? So the frequency density now for that class, let's say frequency density, whereby the frequency was 14, because the number of adults is the frequency, 14 over the class width. The class width was from 5 to, I mean, from 15 to 20. So the difference is actually 5. So if you actually divide 14 by 5, you're going to get 2.8. So that shows you that the height of this bar over here, like there, it's 2.8. So we can safely now we can now safely come up with the scale of these values of here. So if this is 2.8, this is actually 3. So if this is 3, that means this is 2. That also means this is 1. So each small box is representing 0.1, right? 0.5, here's 1, and then here 1.5 is 2, 2.5, 3, 3.5, and this is actually 4, and it goes on and on like that. All right. And then there is something else that they told us. Let's have a look at the diagram. They say that none of the others ran more than 55 kilometers. Okay, we know that. Okay, so now we have to come up with the I mean the frequencies of the other class widths that we have, right? So from 15 to 20, we now know that it's actually 14. They told us that. And then we need to find the frequency of this class here from 20 to 35. So this is actually 35, right? So from 20 to 35, the frequency density, according to this histogram, is 3.4, because you just draw from here the height of the histogram is going to show you the frequency density. So this is just 3.5 because it's 3.4 minus 8 is 3.5. So if you want to come up with the like frequency of the class width of 20 to 25 of 20 to 35, the frequency density is 3.4. All right. We don't know the frequency. You want to find the frequency. And the class width from 20 to 35 is actually 15, right? It's actually 15. Yes, it's 15. So if you want to find the frequency, you're just going to multiply 3.4 and 15, right? So if you multiply 3.4 and 15, you're going to come up with a certain value, right? 3.4 times 15 is just check on the calculator. So we just have 3.4 times 15. So it's 51. All right. So we're going to get 51 here. So this frequency is 51. And then we look at this other frequency over here from 35 to 55. The class width is actually 20, right? So we just do the same thing here to find the frequency. So it's frequency, and then you look at the height of this histogram over here, the bar on the histogram. You can see that it's actually 0.4. So this is 0.4. So you do the same thing, 0.4 multiplied by the class width, which is actually 20. So if you multiply 0.4 times 20, you're going to get 8. So the frequency here is 8, right? So what we actually know is that the total frequency is 100. So we want to find out the frequency of the remaining class, which is 5 to 15, right? So to find the frequency of class of the class of 5 to 15, you're gonna do 100 minus the total of what? Of 14 plus 51 plus this 8 over there. All right. So if you do 100, all right, because we're going to be subtracting all that, you probably get 27, right? So you now have 27, and then you need to come up with the frequency density of 5 to 15. The frequency density of 5 to 15. So the frequency density, right, of 5 to 15, of course, the frequency, you now know that it's 27. And then the class width is 10, because 5 to 15, that's the class width is 10. So it's going to be 2.7. That is the frequency density, which is the height of the graph. So you're just going to go to a 2.7. So this was 2.8. So 2.7 should be somewhere there, here, right? So when you're drawing the graph, you just draw your straight line from here to there. And then, of course, you're going to be using a ruler in the exam, just for it to look perfect and neat. So this is how you're going to draw it. So from 5 to 15, right? And then um, that is how you complete that histogram over there. All right, so they wanted you to complete the histogram. That's how you complete it. All right. Okay, we move on to the next question, which is question number 23. All right, so this is what we have on question number 23. Um, Let's say the solid shape is made by removing a hemisphere shown shaded. So this is actually the hemisphere, right? Uh, from a cone as shown in the diagram, and the radius of the hemisphere is actually 2x centimeters, and the radius of the base of the cone is 5x centimeters, right? So let's just put down the value. So of the hemisphere, let's say it is 2x centimeters, and then let's say radius of the what of the cone from here to there, right? It's, let's say, 5x. They also gave us the vertical height of the cone. So the vertical height of the cone is from here down to there, which is actually 6x. All right. And then they say that the volume of the solid shape is 6,948. Okay, so the solid shape, from this part right here, a solid shape is made by removing. So if you remove this hemisphere from there, you're gonna remain from. I mean, if you remove the solid hemisphere from this cone, you're gonna remain with the solid shape that they're talking about, right? So in other words, we're trying to say to come up with the volume of the solid shape, right? Volume of solid shape, right? It's just equal to the volume of cone minus volume of hemisphere, of which a hemisphere, it's half a sphere, right? Half a sphere. Okay. So in order for us to come up with a certain expression that we can use over there, uh, the volume of the hemisphere, okay, volume of the cone, we use 1/3, right? A pi r squared h. And for the volume of a hemisphere, since the formula to find the volume of a sphere is 4/3 pi r cubed, you actually have to half it. So you multiply by half since this is a hemisphere. So if you use this expression over there, you're going to come up with the volume of the solid shape. So the actual that the volume of the solid shape is it says 6,948. So we're going to use that. Let's just go here. Okay, and use that relationship that we have over there. So we're going to say 1/3, right? Pi, and the radius of the cone is 5x. So 5x squared. Okay, let's just put 5x and then square it. And then the height is 6x, right? Minus half of the hemisphere. So that's going to be 4/6, isn't it? So 4/6 pi r cubed. pi r cubed, right? So pi r cubed, the radius is going to be, the radius is what? Is 2. So 2x, and then we cube that. We cube that. All right. All right. So if you are going to square this, okay, let's just expand it. So we're gonna have pi over 3, right? So it's pi over 3, right? And then if you or multiply, if you square 25x, I mean 5x, you're gonna get 25x squared. So we have 25x squared, and then we also have because we're multiplying all that, we also have 6x minus 4 pi over 6. Uh, and if you cube this, you're going to get 8 times 8x cubed. All right, this is okay. So I'm just going to get rid of this 3. I'll put it 2 here, right? Maybe if I get rid of 2 here, I'm going to get it 2 there. 2 here, get it 3. 2 times 8, I'm get 16, right? So at the end of the day, I'm going to have 25 x squared times 2x. So that's going to be 50x cubed pi, right? Because we still have this pi over there. So 25 times 2, that's 50, and then x squared times x, that's x cubed. And then we're going to subtract 2 pi times 8x cubed. We're going to get 16x cubed pi again, but all over 3. This is equivalent to the volume that of the solid shape that actually remained, which is 6,400 and 6,948 pi cubic centimeters, right? Okay. So with this expression now, we can actually find the value of x. We can actually find the value of x using that. We can actually find the value of x using that expression over there. All right, so the value of x is going to be a, let's see what we can do here. We have that, and then we also have that. If we get rid of the pi, so we can safely say that we have 50x cubed minus 16x cubed. Let us actually get rid of the x cubed. Let's factor out the x cubed. I think that's much better if we factor out the x cubed. It's much better if we factor out the x cubed. So we now have x cubed, and we also factor out the pi. So x cubed pi, right? We're going to remain with 50 minus 16 over 3 is equal to 6,948 pi. So this pi and this pi gone, all right? So the value of x is going to be, let's say x cubed, all right? It's 6,948 divided by 50 minus 16 over 3, right? All over. So this whole thing, you find the cube root. We do the same thing here. We find the cube root of this guy because we want to find the value of x. All right, so we could actually use that to come up with the value of x, right? So the value of x will probably be 5.378. 5.378, blah, 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 blah. All right. Okay, so now we actually have the value of x. We have the actual value of x. They now want us to find a question wants us to work out the total surface area of the solid hemisphere, right? Total surface area of the solid hemisphere. All right. So in order for you to, so it's actually this guy over here. We need to find the total surface area of this guy. So the first thing that we know is the surface area of a sphere, right? So surface area of sphere is 4 pi r squared. But this is not a full sphere, right? It's half a sphere. So we actually divide this by 2 so that we come up with 2 pi r squared. But we also have this circle here, right? So we're going to add the area of this circle because the curved surface area is 2 pi r squared, but we also have this area of a circle over there. We need to add it so that we come up with the total surface area of the hemisphere, right? So we're going to add plus pi r squared onto this so that if we now want to find the total surface area of a hemisphere, we use this 2 pi r squared plus pi r squared. It's going to be equal to 3 pi r squared, right? Of which the value of r, we actually got the value of x, right? So the total surface area of the sphere is going to be 3 pi r squared. The radius of the hemisphere was 2x, right? So it's just a 3 pi, and then your radius is 2 2x 2x squared, which is actually 4, and then 5.378 squared. Okay, so we're gonna have that. Okay, perfect. All right, and then from there we can actually find the total surface area of the hemisphere, which is going to be 1000, right, and 90. And of course, it's square centimeters, isn't it? Square centimeters. So that's what you do. That's what you do over here. That's what you do over here. Okay. All right. So let's move ahead to question number 24. So yeah, of course, you write 1090 here, because that's where you always have to put your answer 1090. All right, so in an exam, of course, you have to make sure that you show all the working. So that's why they give you all this space so that you show them all the working. All right, so let's move on to question number 24. Question number 24 is saying that a polygon has n sides where n is greater than 5. The interior angles of the polygon form an arithmetic sequence. The smallest angle of the polygon is 84 degrees. The common difference of the sequence is 4 degrees. Work out the sum of the interior angles of the polygon. Show clear algebraic working. So what we've been given is that the smallest angle of the polygon, that is A, which is the first term of because it's an arithmetic sequence, right? So if it's an arithmetic sequence, that means the smallest is actually the first term. So the first term is actually 84 degrees. And we've been given the common difference as well, which is D. It's actually 4 degrees. So they say that they want us to work up the sum of the interior angles of the polygon, right? So sum of terms in an arithmetic sequence is actually equal to n over 2a plus n minus 1, and then you multiply the common difference, all right? So probably put a square bracket here, right? And if you want to find the sum of interior angles of a polygon, right? Sum of interior angles, right? You use n minus 2, whereby n is the number of sides, and then you multiply by 180. All right, so we now have these two expressions that we have over there, because they actually want us to work out the sum of the interior angles of the polygon, right? So the first thing that we have to do, we actually have to find the value of n first. And if we find the value of n, we can now we can actually use the value of n to find out the sum of the interior angles of the polygon, isn't it? So the first thing that we have to do, I'm going to equate um, these two equations, right? Because they mean the same thing, right? They are both giving me the sum of the interior angles, isn't it? So I now have I'm going to substitute the value of A and D in the first equation, right? So it's I'll first just write the two equations when I'm equating them. So I'm saying this 2 is n over 2 multiplied by 2a plus um, n minus 1 and the common difference, right? I'm equating it to n minus 2 multiplied by 180. So my n, I don't know what n is. I want to find the value of n. So it's 2 times 84 plus n minus 1, and then the common difference is actually 4, right, is equal to n minus 2 by 180. So I can actually take this 2 over to the other side, just get rid of this 2. All right, so it's just like I multiply by 2 here, and then I'm going to multiply everything by 2 there. So as to just get rid of this 2, right? So it's now n 2 times 84, that's 168. So it's 168 plus, so this 4 times n is equal to 4n, right? And then this 4 times minus 1 is equal to minus 4. So that will be equal to 180 times 2, that's 360. And then 360 times n, that's 360n, right? And then 360 times 2, that's like 720, yeah? So 720. Okay. All right. So you now have 720 over there. Uh, so you now try to combine this whole equation, right? So the first thing that I have here is 168 minus 4, that's 164. And then this n times 4. So I now have 4n squared uh, plus 164n. And then I'll take this negative 360 from this positive 360, my bad, from this side. So it becomes um, negative 360n, and this 720 becomes plus 720 is equal to 0. So I'm just coming up with a quadratic expression. So now I have, let me check if I can divide throughout by 4. So if I divide 164 by 4, I'm going to get 4 and 1. So yeah, I think I can divide throughout by 4. So if I divide throughout by 4, here I'm going to get n squared, right? 164 divided by 4, I get 41. So it's plus 41 n, right? And then 360 divided by 40, that's 90. So minus 90n, and then 720 divided by 4, that's 180. So plus 180 is equal to 0. So I now have n squared, and then 41 minus 90, I'll get 49, negative 49, and plus 180 is equal to 0, right? So if you still remember that other method that we discussed about, whereby if you want to fully factorize a quadratic equation, right? You multiply the first term and the last term, and then you look for two numbers that actually give you a total that if you add them, you get a total of minus 49. If you multiply them, you get a product of 180. So the first term and the last term is n squared times 180. So I'm going to get 180 n squared, right? So I'm going to look for two terms so that if I add them together, they're going to give me negative 49, right? And then if I uh, multiply them together, they give me positive 180 n squared. So I'll get negative 45n and negative 4n, right? So I'll take the original equation, which is n squared. So n squared, and then I'll replace minus 49 with minus 45n, and then minus 4n plus 180, right? And then, I pair them up. Here I'm going to factor out an n. So I now have n minus 45. And then there, I'm going to factor out a 4, right? So it's going to be minus 4. So n, so this minus is going to affect the plus inside the bracket. So it also becomes minus here, right? So if you divide 180 divided by 4, you're going to get 45 as well. So 45. So you now have a repeating bracket, which is n minus 45. So it's n minus 45. That's the first bracket. And the other one is just n minus 4, right? Because all of them are equal to 0. So the two values of n is equal to 45 or 4, right? So we now have the two values of n, 45 and 4. 45 and 4, right? Um, so we're going to use those two values to come up with say, work out the sum of the interior angles of the polygon, right? They want us to come up with the sum of the interior angles. So if I do, if I'm using n as equal to 45, using n is equal to 45, right? N is the number of sides, right? So eh, I'll just use, because they said the total number of interior or the sum of interior angles. So sum of interior angles, remember, sum of interior angles is equal to n minus 2 times 180, right? So we just take n as 45, so it's 45 minus 2 times 180. So that's 43 times 180. This should give you 7,740. So it's 7,740 degrees. 7,740 degrees. We can use 4. No, we can't use 4 because 4 is going to give you, the smallest number of interior angles. So it's not 4. It's actually 44. The number of sides is actually 45. And then we use that 45 to find the number of what? Of interior angles, the sum of interior angles, my bad. So we now move on to question number 25. So question number 25 wants us to complete the square. So they say that write f of x in the form a minus b, x minus c, and then x minus c, all of it squared, where a, b, and c are constants. Where a, b, and c are constants. All right. So we have 17 minus 3x squared plus 12x, right? So the first thing that I do when I'm completing the square is to get rid of the coefficient of x squared. So the coefficient of x squared is actually minus 3. So I'm going to factor out minus 3. So if I factor out minus 3, I'm going to come up with 17. It's negative 17 because this was positive. So it's now negative 17 over 3 plus x squared minus 4x, right? So I now have this. So I can now easily complete the square of this term inside the bracket because the coefficient of x squared is now 1. So it's now easy for me to complete the square. All right. So I'll put a minus 3 and I'll put this square bracket is equal and then inside there is 17 over negative 17 over 3 plus, I'm completing the square now. So it's x squared minus 4. So you always have to divide the coefficient of x by 2 when you're completing the square. So you now have x minus 2. You square it, then you subtract with the square of the number, right, that you have inside the bracket, which is minus 2 here. Right? So if you have, so you just subtract minus 2 there, right? So you're gonna end up with 4, right? So it's actually minus 4. right? You're going to have minus 4 there. So you now have minus 3, negative 17 over 3. And this one is 4, but it's actually minus 4 because of this minus here, right? So it's negative 2 times negative 2. It's positive 4, but it's because of this negative, it becomes minus 4. So you subtract minus 4 here, and then you now have x minus 2 squared, like that, right? So you have your minus 3, open your square bracket. So minus 17 minus or over 3 minus 4. So this minus 4 as a whole number is actually minus 12 over 3, right? So if you do minus 17 minus 12, you're going to get minus 29. So your answer is going to be minus 29 over 3, right? Plus, I forgot to put a plus here, right? So plus a x minus 2 squared, right? And then I'm going to multiply by minus 3 throughout. So if I multiply by minus 3 throughout, this minus and this minus becomes positive. So it's now 29. And this 3 and 3, they cancel out. And this plus here, this whole thing, it becomes minus 3x minus 2 squared. So this is your answer now. So the value of A is going to be 29, right? And then the value of B is 3, right? And the value of C is actually 2, isn't it? So you now have 29 minus 3x minus 2 squared, right? So this is all we had for the May 2024 paper. I hope it was very helpful to you as well. Until we meet next time, it's goodbye for now.